Hello, this video is going to go over how to solve a one-step equation. It will have 4 videos, one for each type of inverse operation. So our first example is x plus 4 equals 14. Our goal when we solve an equation is to get the variable by itself. I want to know, what does x equal? So what I'm going to do is I'm going to put a line down my equal sign, and I'm going to use inverse operations to help me isolate the variable, meaning get x by itself. So to get x by itself, I'm going to have to get rid of this plus 6. Well, the inverse of plus 6 would be minus 6, and I need to do that to both sides of my equation. A plus 6 and a minus 6 cancel out because they're inverse operations. So if I bring down what's left over, which is the variable x, and calculate the other side, 14 minus 6 gives me 8, I now have completed my problem because the x is isolated, it is by itself. But I want to check my answer. So I'm going to take the original problem, x plus 6 equals 14. And I'm going to replace the x with the answer that we just calculated. So instead of the x, I'm putting 8, but I'm keeping all the other numbers the same, so plus 6 equals 14. Now, I need to calculate, does 8 plus 6 make 14? Well, if I use my calculator or use my fingers, whatever you got to do, 8 plus 6, that makes 14, which is what we needed it to equal. So that's how I know that my answer of x equals 8 is correct. Our second example, x minus 9 equals negative 1. Again, I'm going to put my line down the equal sign to help me separate my sides, and I want to get the variable x by itself. And to do that, I'm going to use inverse operations. The inverse of minus 9 would be plus 9, and I need to do that to both sides. A minus 9 and a plus sign cancel out. If I bring down what's left over, that's my x. And if I calculate the other side, negative 1 plus 9 is 8. Now again, I want to check my answer. So if I take the original equation, x minus 9 equals negative 1, put my line down the equal sign, and I'm going to replace my x with the answer that I got when I calculated. So I'm going to do 8 minus 9 and make sure that equals negative 1. Well, 8 minus 9 does equal negative 1, and that's how I know that my answer is correct. Third example, negative 3 times x equals 12. Put my line down my equal sign. The inverse of multiplication is division, so to get the x isolated, I need to divide by a negative 3. And again, I need to do that to each side. Because multiplication and division are inverses of one another, my negative 3's cancel out, and all that is left over is my isolated x. Calculate the other side. 12 divided by negative 3 is a negative 4. But again, I need to check my answer. So starting with the original equation, I'm going to replace my variable with the answer that I got from my previous calculations. So I'm going to have negative 3. And when I replace this x, I'm going to put it in parentheses. I always do that when I'm handling multiplication or division. So I have negative 3 times negative 4. And I want to make sure that that indeed does make 12. So if I calculate negative 3 times negative 4, I get 12, which is exactly what I wanted. And that's how I know that my answer is correct. Last example, x divided by 5 equals 2. Put my line down my equal sign. The inverse of divide is multiply. So I'm going to multiply each side by 5. Multiplication and division are inverses, so my 5's cross out, and all that's left over is my x to bring down. 2 times 5 is 10 when I calculate the other side of my equation. And again, before I finish, I'm going to check my answer. So start with my original equation. X divided by 5 equals 2. I'm going to plug in the answer that I got from my previous calculations, which was 10. And I'm going to make sure, does 10 divided by 5 equal 2? Well, it indeed does. So that's how I know my answer is correct.